Hello and welcome to the fifth webinar within the Flexisoft webinar series. In this webinar we're going to be looking at configuring a Flexi Line project. My name is Ian Keatley-Smith. I am one of three functional safety engineers at SICK UK. The other two are Seb Strutt and Martin Kidman. And we also have a number of sales engineers who are trained up to functional safety technician level. So rest assured, whoever you're talking to, you should have some experience of machinery safety to help you with your inquiries. The agenda for today is, first of all, to understand what is Flexi Line, and then we're going to go in and we're going to look at configuring a Flexi Line project within Flexisoft Designer. And to do that, we'll be looking at the hardware, looking at assigning inputs and outputs, designing safety logic, looking at the reporting structure that you get from the software at the end, and then we'll look at where to get more information from, and finally looking at future webinars that are coming within the series and ones which have already gone, and there's recordings of all the webinars if you want to look at them offline later on in the future. So first of all, what is Flexi Line? So Flexi Line is a network solution and it's used for connecting multiple Flexisoft controllers together. The previous webinar to this one was called What is Flexi Link? And again, Flexi Link looked at the connection of safety controllers. So with Flexi Link, if you haven't seen that webinar, by all means go back and look at that one. But Flexi Link allows you to connect up to 4 controllers together. With Flexi Line, we have the ability to connect up to 32 controllers together. And how we achieve that is through a twisted pair wire, as shown in the left hand side there. So what happens is you have a twisted pair wire which comes out of one controller and then goes into the next, and then out and in, out and in, and it's basically a series connection of the Flexisoft controllers through that twisted pair cable. You'll see as well that you have a number of LEDs built into the CPUs. So we have an MS LED, which stands for module status, a CV light, which stands for code validated. We then have a dedicated LED here telling us the status of the Flexi Line, and then we also have 2 LEDs here which are for EFI, which stands for enhanced function interface. So in order to have Flexi Line and have the functionality of Flexi Line, you have to use what's called CPU 3. So there are 4 CPUs available to you within Flexisoft Designer, and you have to use the highest one, CPU 3, to get this line. Now the maximum distance between each of these CPUs is 1 kilometer. So it's a system which can be used to cover vast distances. So imagine you've got 32 controllers connected together with 1 kilometer between each controller. You can see that we can go, large distances with this Flexi Line solution, and it's all over a twisted pair wire. So what we do is we have what's called a common process image that all the CPUs use, and you'll see that explained later on as we go through the webinar, where I'll give you a typical example of how it works and try and take it down to its basic level. And the system has what's called a teach-in function. So once you have got all of your controllers in and you've connected your line, you then have to teach the line. And that's basically teaching it to say what controllers are there and which ones aren't there. So you can actually teach controllers in and out of the process. There's no addressing required when it comes to the CPUs. So there's no dip switches, there's no software addressing, nothing. It's all done in the background for you, so it's nothing to worry about. All you've got to do is have a common process image. Now the communication works by having a previous station and a next station, and you can see that clearly highlighted there on the CPU 3 itself. Another thing you'll just see on here is you have a standard M8 connector here for programming, but with the CPU 3 we also have the option here to program it via a USB connector. So 2 different options to program the CPU 3. Whereas the CPU 0, 1 and 2 can only be programmed through this M8 connector unless you're using an Ethernet based diagnostics card. So it's quite simple to wire up. All you have is you've got your, as you can see up here, you've got 2 wires and they go to your that goes to your previous and your next, and previous and next. So it's a very, very simple system. And as I said, stations can be removed and added. Every time you remove a station or add a station in, you have to reteach, and that reteaching is done either by a software command within the logic, or it could be done by connecting Flexisoft Designer software to the CPU and teaching it from there. So two different ways of teaching. So here is an example of how this system works. So what we're going to look at here is an emergency stop and a reset signal. So you can see up the top here we have what's called the process image, and all of these controllers down below are all talking and listening to that process image. So imagine first of all that all of our machines are running. So you can see all the motors running down at the bottom there. What we're going to do is press an e-stop on the left hand Flexisoft unit, and you can see the e-stop flashing there. What will happen there is the motors at that station will stop. It will then send a signal up to the e-stop in the process image, and the other controllers will see that an e-stop has been pressed, and they will stop their local motors as well. So let's watch this. So we press the e-stop and the local machine stops. Then it sends a signal up to the line, which is then consumed by the other two, and their machines stop in turn. So that is how we share e-stop data between the different controllers. Now if we look at the reset signal, so here's the reset, and what we're going to do is we're going to reset from the center station. So when you press that, what will happen is first of all the local machine will start to run, so you can see the motors turning, and then it will send a signal up onto the process line. So there's the signal going up, and the other two controllers then consume that reset signal, and their local motors then run. So hopefully that's understandable, because what we're going to do now is we're going to look at how you actually configure this within Flexisoft Designer. So first of all, we have to understand the safety requirements. So we're going to just keep it nice and simple and have two machines, and between those two machines we have 1 kilometer in distance. Machine 1 has an e-stop and reset, machine 2 has an e-stop and local reset, machine 1 also has a light curtain, machine 2 has a switch, a door switch. So how we want this system to work is if an e-stop is pressed on any of these machines, I want all the machines to stop. So if I hit an e-stop on machine 1, I want machine 1 to stop, and I also want machine 2 to stop, and vice versa. The light curtain on machine 1 will only stop the local outputs on machine 1, but when I open up the gate on machine 2, I want to stop the local outputs on machine 2, but I also want to switch off machine 1. So hopefully that is understandable. So let's move that over to the side. We'll keep it there just so that you can keep a reference to it, and we're going to open up Flexisoft Designer. So the first thing we do is we click on Create a New Project, and that will then open up the user interface for Flexisoft. And we have the option of our CPUs. So there's 0, 1, 2, but because we're using Flexi Line, we're going to use the CPU 3. And then the CPU 3 goes into the configuration area. I'll grab an XTIO module, and now I'm going to start putting some elements on here. So I'm going to add a dual channel e-stop. Now I also need to add a reset push button, so I'll grab a reset and add that onto input 3. And I also have a light curtain on machine 1, so go and choose a light curtain, and we'll choose the DTEC 4 and add that on there. And then I'm just going to go and select some outputs. So we're going to go for a motor, which we'll put on Q1, and a lamp, which will populate onto Q2. So that's us done our inputs and outputs, and now we're going to add a Flexi Line. So we just click on here and then drag that over and drop it down onto the line. Now you have the option here of going for a new definition or an existing, so we're going to have a new definition. And first of all, you can see there's a unique checksum for the actual definition. We also have the ability to import and export definitions. And we want to go 1 kilometer between machine 1 and machine 2, so we drag this cycle time over until it goes green, click on the 1 kilometer, and then we go to the byte, and we have 4 bytes of data that we can send at that scan rate over a kilometer. So we're going to call this the e-stop, and this safety switch, or safety gate. There you go. Now down here you can send the information to all available stations. You can send it just to its neighbours, you can send it just to the left, or you can send it just to the right. So you can decide how you want that information to be transferred. I would like to send it to either side, and you can select this byte to be low or high. Now low is usually for a reset, so we're going to choose high because we're looking at e-stop signals and safety gate switch signals. So bit 0, we're going to call this the emergency stop, and then for bit 1 I'm going to call this the safety gate. So that's the only 2 bits that I'm going to put onto the process image. I then go into logic, and just make this a bit bigger so we can see it. There is my emergency stop signal. I'm then going to pick up a routing block. Now if you're not familiar what these blocks are, there's a section, a webinar session going through these blocks here that we're talking about, so you can go back and look at that. Now what I'm going to do is I'm going to send that e-stop status up onto the line. So I just attach that to the output of the routing block, and then I'm going to go and get a reset block, and I'll just drag that over and drop it down. I'm going to double click on that, and for the I/O settings I'm going to select 4 inputs. Now when I go over to the input section on the left here and choose a reset, I attach the reset to the reset input. I attach the light curtain to release 1, and now I'm going to go to my Flexi Line because I want to bring over the e-stop, which is on the line, and I also want to bring over the safety gate, which is coming from machine 2. Now we're going to go and simulate this just now, or just before that actually. We'll go and put our local outputs on. So there's my motor, and there's my reset required lamp, which I'll put on there. Right. So we've done our inputs, we've done our outputs. We'll go up and click on the simulator button now, and we'll put that into free run. Now the e-stop is healthy, so that means the e-stop's healthy, the line is healthy for e-stop. That in turn will put this input here high. Let's assume the safety gate's closed, the light curtain's clear. I then get the lamp to say reset required, press and release the reset, and the motor runs. If I hit the e-stop, what that will do is bring the line down, which in turn will bring that off. So it will stop the motor. So that would go off, then that would go off, and it stops the motor. Put the e-stop healthy again, the line will go high, that goes high, and now we can initiate a reset to get our motor running again. So hopefully that is understandable there. As you can see, if I were to activate the DTEC 4 light curtain, it would knock the motor off. When it was clear, it would require a reset. However, it wouldn't have any effect on the other machine because I'm not sending the light curtain onto the process image. So that is machine 1. Now what we're going to do before we go ahead and start doing machine 2, I need to save this this profile for the Flexi Line. So I need to export the line configuration. So to do that, I'm going to go up to interfaces and go to the Flexi Line, and then I've got this option to export this configuration. So all I'll do is come down here, and I'm going to type in demo underscore webinar and hit save, and that saves that configuration. So once I've done that, then I will then go and start working on machine 2. So for machine 2, we open up another instance of Flexisoft Designer, we create a new project. And just to point out here, when you're doing Flexi Line, you have to program each station individually. So here's CPU 3 again. for our machine 2. There is our, we're going to bring in our XTIO, and on machine 2 we've got, as you can see on the left hand side there on the image, we've got a dual channel e-stop, we've got a reset push button, and we also have a safety switch. So there's the e-stop, there's my safety switch. You can see there's lightning bolts there because they're using test pulses. There's my reset push button, and then I'll add in some local outputs on there as well, as we did before. So we have a motor from Q1 and a reset required lamp which we put onto Q2. Then we go and pick up our Flexi Line and drag that over and attach it on there. And rather than creating a new one this time, we're going to go for the existing Flexi Line definition, and we're going to pick up the demo webinar file. Now when we do that, when it opens up here, you'll see that first of all the checksum is exactly the same. We still have a kilometre, 32 bits, and when we go into the byte configuration, what you can see is that, if we just bring this running it, there we go. There's your emergency stop, and there is your safety gate. So let's go in and start doing the logic now for this. So just make this bigger again so you can see better. So there's my emergency stop, and there's my safety switch. Now both of these signals will be going up onto the process image. So we're going to go for routing end to end, bring that up, and then play a game of join the dots again. So e-stop goes to input 1, and your safety switch goes to input 2. I'm then going to go to outputs on the Flexi Line, and there's your 2 bits from your process image that you've defined before. So there's the emergency stop and the safety gate. So the emergency stop in machine 1 affects that bit e-stop on the line, as does machine 2. I'm going to grab my reset push button, or my reset block, double click on it, and this time we're just going to have 3 inputs, and say OK to that. We have our local reset, which goes to our reset input, and then we have the emergency stop from the line, which will go to release 1, and we'll also take the safety gate and attach that onto release 2, like so. We'll go to our outputs, go to our XTIO and take our motor over, and then we'll take the lamp over as well and attach that onto reset required. Hopefully this is all making sense. Then we're going to simulate it. So I just actually better hit the play button on the simulator. There we go. So the e-stop is healthy and the gate is closed. That means that those bits there will come on, and we can then reset machine 2 and get the motor running on machine 2. If we press an e-stop, then the e-stop will drop. Now it's also dropping on machine 1 here as well when you press the e-stop. So machine 1 and machine 2 would require resetting in this example. If I open up the gate drops. Again, machine 1 will be stopping because it's looking at that safety gate bit in its logic, and that's it. So we've now written the software for machine 1 and machine 2. It's quite simple. Like I say, we've only got 2 bits going up on the Flexi Line, so we've got the emergency stop and the safety gate going up there. So what we'll do now is we'll go in and start to have a look at the report. So to get to the report, it's just up here at the top bar here, click on report, and that will open up a report for machine 2. So you'll have to have a report for machine 1 and machine 2, and this report will form part of your technical file. There's your part numbers, and then if we scroll down, again I pointed this out in every webinar, there is your vital information with your CRC checksum and when it was verified and the date and time. Down here you have your logic. This is for machine 2. If we keep scrolling down, you'll then see how it should be wired. So we have a test pulse coming out of X1 through that contact to input 1, X2 through the second into input 2, and the same for the safety switch. So we're sending a digital waveform through there, 24 volts into the reset, and there's my local outputs. And here is my Flexi Line information. So you can see it's 8 millisecond cycle time, 32 bits, 1 kilometre, the baud rate there, and then you've got the checksum for the line at the end. And then down here you've got your configuration of bits, so there's your e-stop, it's just sending it to its neighbours. And the default value is 1, so whenever you hit an e-stop you're dragging that 1 to a 0. So all the information is there for machine 2, and you would go and do exactly the same for machine 1. The report would look very similar, but obviously the logic would be different, but the details on the Flexi Line would be the same. It would be the same checksum there. So where to get more information on all of this? The best place to go initially would be the SICK website. So where it says I am looking for there, simply just type in Flexi Line and it will direct you to the appropriate web page to get more details, where you can get manuals and things like that. Another great place to go to is the YouTube channel. So if you haven't already, make sure you subscribe to this, but just click on the search bar, type in Flexi Line, and you'll see there is a raft of videos going through it. So I've covered this quite briefly today, because I tend to try and keep these webinars quite short. There is a whole section there on Flexi Line, so there's 6 videos which are packaged up in total, which just cover Flexi Line, so that will go through it in a lot more detail. But at the end of the day, if you do want to get in contact with us to discuss anything, then our details are at the end of this webinar. So future webinars, just webinars that have been done already. So we have the Introduction to Flexisoft webinar. If you haven't been on that one, then they're available to download on demand, and you can watch a recording of them. Webinar 2 looks at the function blocks, and it looks at the function blocks we've looked at today, which are the routing blocks and the reset block, as well as others. Webinar 3 looked at Flexi Loop, which is a little sort of discrete remote I/O loop for your inputs and outputs to switch gates. So that's webinar 3. Webinar 4 looked at Flexi Link, which dealt with the connection of up to 4 Flexisoft controllers together over a maximum distance of 100 meters. So that is the Flexi Link one. You are currently watching the Flexi Line webinar. The next one in the series is covering diagnostics. So we'll be looking at the diagnostics cards in Flexisoft Designer and how you get information up to the PLC to then portray what's wrong with the safety system or the current state of the safety system on your HMI. And you can also bring data from the PLC down to Flexisoft as well. So all the diagnostic cards that we have are bi-directional. And the whole purpose, this is one of the key webinars really, because at the end of the day, if we can pinpoint exactly where a problem is in our machine or where the error is, then it's going to get the maintenance teams to the right place at the right time and get the machine back up and running as quickly as possible. So, as it says there, reducing the downtime and increasing the productivity. Webinar 7 is the final one in the series, and what we're going to do is look at a robot palletizer. So we'll take it from complete scratch and we'll build a project up as to how you would maybe put a system like that together. If you have any questions or anything at all, you want to discuss projects, or you need more information on Flexisoft, then by all means get in touch with us. My details are at the bottom left there, so Ian Keatley Smith, and it's shortened to make it life easy for you, so it's ian.ks@sick.co.uk and my telephone number there. There's also details of Martin Kidman here. So Martin is based up in Liverpool and he's also a functional safety engineer. So if you need to talk, if I'm not available, by all means get in touch with Martin. But between the two of us and the other members of the team, I'm hopeful we'll be able to answer most of your questions and get back to you with everything you need. So thank you very much for your attention. I hope that was useful, and have a good day. Take care. Bye now.